Hello, how are you? Okay, today we're going to look something we call is stoichiometry. This is the part of chemistry, particularly in the part of mole concept that based on the balancing the chemical equations and related moles to find different amounts of substances, either in part of product or reactant. So in simply look on this. This word is stoichiometry. This means chemical arithmetics. Why you say chemical arithmetics? By click words, you know that this word is made up of two click words, that is station and metron. In part of stations, we mean that element or part, but metron, this is the Greek word which means measure. So by definition, we can say that stoichiometry is the study of the numerical relationship in chemical formula and reactions. So here we try to look on how the chemical reactions is occurred between a species and the balancing the chemical formula of that species that taking part during the reactions. So by knowing the stoichiometry of the formula allows us to relate moles and grams for particular reactant or product. For example, 1 mole of water. This 1 mole of water is equivalent or equal to 18.02 grams. So through that, relating on that, but this is basically based on the part of calculations. So this is the relation that we call stoichiometry. Knowing the stoichiometry of the reactions allow us to relate amount of different substances to each other using the mole ratio as I said previously in the balancing equations, and allow us to predict how much of the product will be formed or how much of the reactant will be formed. So first of all, we must know any part of product and the reactant. If you balancing the chemical equation in the proper way, it is simply to you to get the real answer or the real amount, maybe the mass or is the volume or the number of moles that are finding from your question that I have asked. So make sure that you make a good consideration in the part of balancing the chemical equation. Let's look at an example from the reaction of stoichiometry. Like here, when this hydrogen gas reacts with oxygen gas to form water. But through balancing the chemical equation, we can look on this side that in the part of the reactant here, this is the reactant that will have the reactant species, that is hydrogen gas and oxygen gas. But by starting balancing these equations, we can look on this end that if you have hydrogen gas, it's reacted with oxygen gas to form water. But from this perspective, we can look that in this side of the reactant, where there are 2 hydrogen, and this side of product there is 2 hydrogens, and in the part of oxygen here there is 2 oxygen, and the part of product there is 1 hydrogen. So we will put here 2 moles in order to make a good considerations of molecules of oxygen in the reactant. So it means that for this side it will be 2, and here it will be 2 oxygen. So from that perspective now, we are going to balance in part of hydrogen. We can look on this side that in the side of product there is 4 hydrogen now, and here we have 2 hydrogen now. So up the end, in order to balance, we will make here 2. So from this consideration of balancing equation in such a way, it will be assist you to make a good correlations in stoichiometry. So for example here, suppose we have 25 grams of oxygen gas. How many grams of hydrogen gas will be needed for these reactions? How many grams of water will be produced? So from this equation that I have provided here, if you are already given this mass, you see, you have already given the mass of oxygen here, that is 25 grams. So if you are already given that, first of all you must change into moles. It means that this mass that I have must be in part of moles. Since here we have given a mass of oxygen, and the molar mass of oxygen you have, that is 32 grams per mole. So up the end you get the number of moles. After getting the number of moles until the end, you are going to let from this number of moles of hydrogen and this of oxygen, and from that value that you obtain from this one. So up the end, if you get the number of moles of hydrogen, then you can find also the mass of hydrogen wherever as you want to find, as our question here asks. So you must follow on these stages in order to make a good considerations on finding these questions. Let's leave it first, but at the end you will understand the more concept how it seems like. Suppose from that questions you have already looked on that, but further we will describe below. We can't convert mass of oxygen direct into hydrogen gas. So it means that it is difficult now to change this mass of oxygen direct to hydrogen gas mass. So it means that the gram of this side you can't change direct to gram of this hydrogen. Why so? Since here we're going to look about the stoichiometric coefficient. It means that you must change into number of moles, then you make a correlation through this number of moles from the balanced chemical equations. So but if we can't if we convert mass of oxygen gas into moles, we can use the coefficient of the balanced equation to obtain the moles of hydrogen gas and then convert it to mass of hydrogen gas, as I said previously. So you must follow this stage. So I have summarized here some aspect that you may follow until you get the good answer from your calculations. As it seems here, you have this structure that I formulate. So by making a good consideration from that, it means that the whole concept of stoichiometry, it would be simple to you to make good calculations. And I know that through considering that, it will be difficult for you to fail to calculate the concept concerning with the stoichiometry. As you see here, we can start on this side, where the mass of known substance. The mass of known substance here, it can be the mass of oxygen. We can take an example. This mass of oxygen. First of all, you must have a mass of oxygen. So this is the mass of the known species. So from that, it means that here we have a mass of known substance. Maybe is the mass of oxygen. Yes, as you indicated from the question above, and this number, this mass of the substance, you must change or convert it to moles of known substance. So it means that you must find the moles of oxygen now by using the formula that is number of mole equal to mass over molar mass. So from that I will get the number of moles, and after that now you're going to back to use the mole ratio to convert into moles of the another species or desired species. So it means that from the balanced chemical equation here, it means that from this part, on this part of consideration, first of all you must balance in a proper way your equation, and also find the appropriate mole ratio. It means that when you balancing, you must write the ratio according to the equation that is needed. Like here, from above here, we have the ratio of hydrogen gas and oxygen gas, that is 2:1. 1. So this ratio, but it might indicated in the form of moles. You must make a consideration on such way, you see. So after the end, mole desired substance divided by mole of non-substance. So from that it means that you will make comparisons between the two species, and after that you will get the number of moles of desired substance by making a consideration. So we will look at below here. So covert that moles that you get of desirable species may be the moles of hydrogen or the moles of water into direct mass of the substance. Here you change it to mass of the substance, or sometimes you can change it to volume, whatever as you want, or as the question needed you to find. So reaction stoichiometry, for example, here we have an equation that we have provided from there. So as I said previously, that if you have given maybe from this question that was shown, see here, suppose you have this question. Now we're going to answer this question. We're going to answer these questions. That I say that suppose you have 25 grams of oxygen gas, how many grams of hydrogen will be needed for these reactions, and how many grams of water will be produced? So how are we going to find on that? Example here. First of all, you must have a balanced chemical equations. As here we have 1 mole and 2 moles, that is already balanced. So from that you must change that mass of oxygen into moles. As I said, this is make a consideration that a number of moles is equal to mass over molar mass, or you can say 1 mole of oxygen gas is equivalent to 25 grams of oxygen gas. So for molecule, or for 2 moles of oxygen, it will be how many number of moles? So up at the end you get the number of mole of what? Of oxygen, through say that number of mole is equal to mass over molar mass, or by making a correlation of 1 moles of oxygen to 2 moles of oxygen, and after that you get the good answer. So from that, now after getting the number of moles of oxygen gas, now you must convert moles of oxygen gas to hydrogen gas. That is the desirable number of moles of hydrogen gas. So it means that if you have a noun mass, you must change into moles. After changing into number of moles, and after that you're going to use the equations. So here we use the equations. By using the equations, note that there is 2 moles of hydrogen gas and 1 mole of oxygen gas. But this one, this number of moles is the one that we obtain from the calculation here. So up the end, it means that you make a consideration that 1 mole of oxygen gas is equivalent to 0.781 moles. Therefore, how many moles will be released from the coefficient of 2 moles? You see, so this one are coefficient on what it is tested in, and the coefficient of what we are cancelled out. So it means that this one are the one that make a consideration in the part of chemical equations. You see, so it seems to be simply like that way. And after that, if you get the number of mole of desirable species, it means that here our desirable species is to find the mass of hydrogen gas. So now we have obtained the number of mole of hydrogen gas through correlating with the chemical equation by using the coefficients. So now we're going to convert this one, that amount that we have obtained, we're going to convert it to mass. So how we can convert it to mass? This one you can use the simple way of rearranging as 1 mole for hydrogen gas here as 1 mole of hydrogen gas is equivalent to this one. So how many moles of this one it would be? So up the end you get the answer. So but for some perspective you can use this one, that is number of mole equal to mass over molar mass, and you obtain the answer since you find the mass, but number of moles you have and the molar mass here you have of hydrogen gas. So at the end you get the answer. So from that I have given you some introductory part that is concerned with the stoichiometry coefficients. So now I'm going to provide some expectations about different questions on how you can make relations, maybe to find the volume, and in much here we're going to find the volume of different gases on how it is exists at STP, at standard temperature and pressure, and several forth. And what expectations I want to you is to make a good consideration in the part of balancing the chemical equations in order to make a good understanding in calculating the stoichiometry equations. So make sure that you make a good consideration. I also say thank you.